Now we go to an important part. We discuss about equipment, freezing equipment. Okay, it's freezer. What are the types of freezers as we have? First, we will discuss what are the factors we need to consider when we want to select freezing equipment. When we want to buy the new system, what do we need to care? So we need to consider the rate of freezing that we need. Okay, we wanted fast freezing, slow freezing, or ultra fast freezing. So we need to know. We need to know, or we need to care the size, the shape, packaging requirements of our food. We consider either we want to operate under batch or under continuous way. Batch means you have a freezer. For example, you put your food, you free your food and you finish one batch and you continue a new batch. Continuous means you have a system, you do continuously. Food enter one side and then it will get out another side, get frozen already. This is continuous. Which one is more flexible? Batch or continuous? Normally the batch system is more flexible. Means that today you can freeze this food, tomorrow you freeze another food, you freeze different type of food. Can allow you to do like that. And the continuous system is more suitable for large scale of processing, but it's less flexible. It's more specific. If you do one or only two type of food for the whole time, and you need a large scale, then you do continuous. Okay, and the other factor we consider is the scale of production, of course, how big, the range of products that need to be processed, and last but not least, the capital and the operation cost. Capital means investment. How much money do you have? Some system is very expensive, some system can be cheaper. So how much you have money from beginning to invest. And the operational cost means how much do you spend when you use a machine every day. For example, if you use liquid nitrogen to freeze your food, then you have to buy liquid nitrogen all the time. You have to supply it all the time. It takes, maybe it's more expensive every day and so on like that. So this also you need to care. For freezing equipment, there are two classes, two groups of equipment. One is called mechanical refrigerator, là tủ lạnh cơ học. Mechanical refrigerator. And the other group is called cryogenic freezers. Cái này gọi là hệ thống lạnh, môi chất lạnh. For this type of freezer, we use cryogen, especially liquid nitrogen, liquid CO2, or solid CO2 to freeze the food. And this cryogen, this we call cryogen là môi chất lạnh, will have direct contact with the food. Like this, the food is transported and then here you spray liquid nitrogen to the food. This is liquid nitrogen. You spray onto the food. What happened with liquid nitrogen here? In the air, what is the state of nitrogen? Normal in our air, the air we breathe, nitrogen is in gas state. Here is liquid because they have to compress it, they have to increase the pressure to make it liquid. So when we spray it into the air at atmospheric pressure, the liquid nitrogen will be converted into gas. And when it is converted into gas, it will absorb the heat or release the heat. Absorb or release the heat? It's absorb the heat. For example, when you boil water, you need to supply in the heat. The water need to absorb the heat, to take in the heat to boil. This is the same. Okay? Liquid nitrogen, when it is converted into gas, it will absorb the heat. It takes the heat from where? From the air. From where? From our food. When you spray like this, evaporation occurred here. It takes the heat from the surrounding air, from the food, and the food lose heat, means that the temperature of the food going down or up, down. And this process is very fast, take the heat very fast. So here actually you have kind of flash freezing. And the temperature, the evaporate the boiling point of liquid nitrogen at atmospheric pressure is minus 196 degrees C. What does that mean? Means that when it boils, means when it evaporates, it generates this very low temperature. So the food is frozen ultra fast, very fast. If you want to break your finger, you can use liquid nitrogen, you spray on your finger, and after a while your finger got frozen. And it's very brittle and you can break it easily. That is how, if you watch Hollywood movie, one of the way they kill monster, they use liquid nitrogen. They freeze the monster and then they can break the monster easily. Because some monsters are very strong against many types of weapons that's in movie. When you watch Hollywood movie, actually you learn quite a lot of science and technology inside. Okay, but if you use liquid CO2, the same at normal condition like in the air, atmospheric pressure, CO2 is in gas form. So when it is liquid, when you spray it into the air, it will boil, it will evaporate, and it will generate the temperature minus 60 degrees C. Liquid nitrogen minus 196 degrees C. Water boils at what temperature? 100 degrees C. Remember, the boiling point is dependent on pressure of environment. At 1 atmosphere, at our pressure, water boil at this temperature, liquid CO2 boil at this temperature, liquid nitrogen boil at this temperature. Okay. Now we go back to the other group, equipment, mechanical refrigerators. Mechanical refrigerators, we have a closed system, like a tube closed inside. And here, inside this, we have also a coolant. For example, freon. And then, what happened with this will be pumped through this system. It goes through 4 stages. So here, one refrigeration cycle has 4 stages, or 4 steps, you would say. The first one is compression. Compression means, here you see, you reduce the volume. You need a pump to pump. This is compressor. Compressor is just a pump to reduce the volume. When you reduce the volume, means you increase in what? Pressure. When you increase pressure, means you increase or reduce boiling points. You increase boiling point. So your reagent, your cryogen is actually when it's here, then it's in already a gas form. The cryogen now is in gas, but when you reduce volume, when you increase pressure, means you increase boiling point, means that the gas will go back to, after that, the gas will go back to liquid. And this component, this is from gas, it's go back to liquid, and this component is called what? A condenser. The process is called condensation. Condensation, conversion from gas back to liquid because you increase the pressure. Like I told you in previous slide, normally nitrogen is in gas form. But how to make it liquid? They have to increase a lot pressure. Here you increase pressure and then you have condensation of the cryogen. And then you go to the next stage. Here, if you look like this, means that it's extension. Extension in volume. Increase in volume means reduction in pressure. Means that you lower boiling point, right? You lower boiling point, then your cryogen from liquid will boil into gas. And this component, this process is called evaporation. Again, what are the 4 processes? Compression, condensation, extension, Evaporation. Some of previous semesters, I gave an exam question here. What are the four processes in a mechanical refrigerator? And I put like this. I put CO dot dot dot, and for the student to complete the word, I put like CON and COM, and I put here like X. I put here like E. It's very easy for you to do. And one student answer here X boyfriend. That's happened then. Maybe some student were still dreaming during making exam. Still you remember these four processes, these four terms, and what happened with the cryogen inside the system. Now we are sitting in an air-con room, right? The air-con, you see that air-con is actually a what? Mechanical refrigerator. At home, actually you have an air-con. That's one port outside and the other port in your room, right? It's the same like an air-con here. At your home, in your room, you have an air-con, and that air-con actually has two components, two ports, right? And one port you call it hot port, and the other port you call it cold port or cool port. Just a normal way, normal language, you call it like that. Okay, I will go back to this example later, but now we need to explain this first. You got the current cycle, pressure enthalpy diagram of a mechanical refrigerator. You studied this already. From 1 to 2, you look from 1 to 2, you increase the pressure. You see, you increase the pressure. And then from 2 to 3, you go from gas back to liquid. This curve, the curve here on the left side, is called saturated liquid curve. If you study, you remember. And this one, this curve is saturated gas. So when you move from number 2 to number 3, you convert a 100% of gas back to a 100% of liquid. When you are at this condition, then 50% is gas, 50% is liquid. When you are at this position, then what? How many percent is liquid? 75% is liquid, 25% is gas. This much proportion is for liquid, this much proportion is for gas, right? And from 3 to 4, you reduce the pressure, mean you go through extension. When you reduce the pressure, your cryogen will start to boil. So it's go from more liquid into more gas. And this one is called condensation. We already said this one is evaporation. Okay, now the question. The question is, which one, 4 to 1 or 2 to 3 is in this part of the airgun? The 4 to 1 or the 2 to 3 is in this part. What do you think? I make it larger here so you can see. Okay, your airgun at home, you have two ports, right? So actually these two ports are connected together by how many pipes? 2. Because you see there is running around. So there's always 2 copper pipes connect this together. Okay? And if you observe at home, you will see that one pipe is smaller than the other one. One larger one, one very small one. The small one is for liquid, the large one is for gas. Okay, you go home and you check, you will see. Now, what do we have? The two main heat exchange here, the 4-1 and then the 2-3. Which one at which part? This is a cooling part. What do you think? 4-1 or 2-3? Here, 4-1. What do you need in your room? You need to cool down the air. Means that you need to take the heat from the air, right? If you need to take the heat from the air, you look at these two stages. Which one absorb the heat? 4-1 or 2-3? Absorb the heat. 4-1. 4-1 is boiling. Boiling means it absorb energy. It take the energy, right? So here you have 4-1. The 4-1 happen in here. 4-2-1. It takes the heat from the air, cool down the temperature of the air, and you feel good. Okay. And what happened is, you see, it's move the air like this, and then the air will go here, and will go back here, and will go down here. Actually, the air in your room is circulated around and around. When the air move inside and in contact with 421, the air will lose the heat. Okay, so here actually they also they have a board here to collect the condensate, and then there is another pipe. They make another pipe. This is just a plastic pipe for the condensate of water. So if you observe, you see that water dripping, dripping, dripping continuously. Where does this water come from? Okay, that air is actually come from, that water actually come from the air in your room. This one, in the air, what do we have? We have vapor in the air, right? What is vapor? Vapor means water in gas form. And this air has a relative humidity. For example, in Vietnam, 85%. When this air moves in contact with the evaporator, this is the evaporator, the temperature of the air is going down. And if you study already principles of food engineering, that's when we reduce the temperature of the air, the relative humidity will increase. The amount of vapor doesn't change. I mean, the absolute humidity means what is the amount of vapor doesn't change. But the relative humidity will increase when temperature is decreased. When it reaches 100, what do you call this? Situation saturated air. Đến trạng thái này gọi là khí bão hòa với hơi nước. And then that start the condensation. 100 là tối đa rồi, nó phải ngưng tụ ra. And then the vapor in the air will condensate here and become the condensate here. So they have to collect this water out. So when you are in the room, you close the room very well. Actually, the air in here is drier than the air outside. So sometimes you feel that your skin is very dry. The leaves are very dry because the air is drier, because it's lose water all the time. Okay, this also is planned for the phenomenon that you see every day, even today, when you drink coffee with some ice, and what do you see on the surface outside of the cup? Drop of water. Where does this water come from? Vapor in the surrounding air. Here, relative humidity may be 85%, but when this vapor going nearer to your cup, temperature is decreasing, relative humidity increasing. When it reaches 100, what happens? Condensation. And then you have the condensate of water from the air. Okay, so now we go back. So this one is 4-1, right? And here you have 2-3 here. Also a compressor here actually. Nó cũng có cái máy nén ở đây nè. So you feel that when it's running, make a noise, running noise all the time. And then here, condensation will release heat, right, to the environment. So there is a fan that blow out the hot air, the warm air all the time. When you stand here, you will feel that it's quite hot. When you stand here, you will feel what? Good, cool, right? So when you enjoy sleeping here, your neighbor is suffering the heat from your aircon. You get the point? So if you want to have a fair life, do not use an aircon. Temperature everywhere is the same for everybody. In our city, the more aircons we use, what do you think about the temperature of the air? Increases or decreases? If we use more aircons, increases. You use aircon in your room, it's going down, but outside it will go up. And we don't have a perfect machine. Means that we have loss of heat. We consume more energy than is needed. Means that in total, we generate more heat than we take out the heat. In this system, the more aircon we use, the temperature of the air will go up, not will go down. Okay? So your room at home, you have a fridge, right? A fridge is only one port. You don't see two ports, but actually, The condenser is at the back. Any condenser? The condenser means the part that releases the heat to the environment. It's at the back. And then the evaporator is at this side. It will take the heat from the air inside. It's cool down the temperature here, but here it releases the heat. So if you put a fridge in your room, the temperature of the room will go up, right? You go home and you use the fridge as an air con. You open the door, you stand here, so you feel cool, right? But your friend stay here. After a while, I think he will suffer the high temperature. Because in generally, we warm up the room. Good. Now, the other group of freezer, we got cryogenic freezer. This I explained briefly already. So we use liquid nitrogen or liquid CO2. You spray directly into the food. This is the food transported in and out continuously. After several minutes, your food is frozen. Very fast. What is the temperature here? Minus 196 degrees. This method is expensive because you consume liquid nitrogen all the time. But it gives you very good freezing rate, very fast freezing rate. And also it gives you a term, you call it IQF. What is IQF? There's this term in the exam. I asked IQF stand for. You have to write there. What is I? Individual quick freezing. Very quick freezing. Individual means the food will be separated one by one, piece by piece. Especially in the southwest of Vietnam, we have many factories. We free fillet of catfish. We free shrimp. Then most of the company they use this method. Very fast freezing. Preserve the quality very well. We already discussed in previous part.